All right, guys, let's do this. Here we are. All right, so we're going to learn some formulas today. Before we do, let's just go over some vocab. When we have simple interest, it's the total interest for the entire length of a loan. So if we say we're going, it's going to compound yearly, what does that mean? How many times if it's yearly? In that time span of a year, how many times will it compound? Once. Okay, also annually. Like if they're having an annual sale, how many times does it happen? Once a year. Semi-annual. Twice. Monthly. 12. And daily. 365. Hey, when we're dealing with simple interest, we have a formula. Well, A is equal to P times the quantity of 1 plus R over N raised to the NT power. All right, let's tell you what these variables mean. So A is going to be our starting amount plus whatever interest has been made. So we call that the principal amount is your starting amount plus interest. P is your principal amount, which we know is the original amount. R is the annual rate. N is the number of times it's compounded. And the T is time in years. So if you're compounded continuously, that's telling us it's infinitely many times in a day. Obviously, you'll make a lot more money this way. So here, the formula is A is equal to P times E raised to the RT power. Okay, variables mean the same thing. A is going to represent our principal plus our interest. P is the principal amount. R is the rate. And T is time. Michael?
Do we memorize all of these?
You have to, yeah. You're going to need to memorize these. All right, population growth. Ooh, I don't want that. So for population growth, our formula is going to be n of t, so n in parentheses t, is equal to n sub 0 times e raised to the kt power. All right, n sub 0 represents our number at the beginning. N of t is going to represent the amount at the end. T is time. And K is our growth factor. Or we could call it our rate of growth. And for K, this is a little bit tricky because it's a constant, which is unique to each problem. All right, and our very last formula is our decay formula. And this is going to be n of t is equal to n sub 0 times e raised to the negative k t power. It means all the same things as the problem above. Do you need me to write them all out again? Okay, all the variables mean the same. All right. Yeah, E is our like 2.7, that same number we've been using for E. Yeah. All right, let's keep going. And now what I want to do is I want us to read through the problem and then decide which formula does this go with. So it says if $1,000 is deposited into a fund yielding an APR annual percent rate of 11%, how long will it take your investment to double if interest is compounded monthly? So go back to our first page. Which formula are we using here? Compounded continuously or just simple interest?
Continuously.
It would have said continuously. It would have said compounded continuously. So this is just saying compounded monthly, not continuously. So you're right. You narrowed it down to the right two formulas, but it is the simple interest. So let's write it out. What's up, Michael?
If it says compounded 365 times a year, would that be the same as compounded continuously?
No, it would have just had to say compounded continuously. All right, so here we're using our simple interest where A is equal to P times the quantity of 1 plus R over N raised to the NT power. Right, if $1,000 is deposited into a fund, what do we think that $1,000 represents? Which variable here? P, it represents our original amount that we had. So we know it's going to be 1,000 for P. And it says into a fund yielding an annual percent rate of 11%. Do we all agree that's our rate? So now we don't want to write it as a percent, we want to write it as a decimal. So how do I change 11% as a decimal? 0.11. How long will it take your investment to double if its interest is compounded monthly? Well, if it's compounded monthly, how many times a year is that being compounded? 12. So do we all agree our n, number of times compounded, is 12? So this is 12. And then it says, how long will it take? So what does that mean? We're solving for t. So this is 12 and this is t. Now if I'm solving for t, I need to know what a is. A is our amount at the end. So our principal plus the interest that it's earned. So it's saying we want our investment to double. So if my original was 1,000, if I want it to double, what is that going to be? 2,000 on this side. Now we have to solve for t. I'm going to try to isolate t as best as I can. So I'm going to divide by 1,000 on both sides. So I get 2 is equal to the quantity of 1 plus 0.11 over 12 raised to the 12t power. Now that I've isolated as much as I can, I need to get that t out of the exponent. Who remembers how we do that in order to solve for it? Log. We're going to take the log of both sides now. So I'm going to now have log 2 is equal, I'm going to just pull that 12t in front. 12t log of 1 plus 0.11 over 12. Do we all agree we're solving for t? And do we also agree that it's multiplication between each of them? So it's 12 times t times the log of that whole quantity? Yes. So if it's multiplication between them, can I just divide it? So I'm going to divide by 12 log of 1 plus 0.11 over 12 on both sides. So this is what we're entering into our calculator. Can I go to my calculator? All right. Yep. All right, so how are we going to enter this in? We're going to press log of 2, close it, divided by, now I'm going to open my parentheses, and I'm going to have 12 log of 1 plus, I'm going to put this in parentheses too, even though I'm not sure if I need it or not, divided by 12. And then I'm going to close all of my parentheses and press enter. All right, so the rule here is you're always going to do 3 decimal points unless we're talking about money. If we're talking about money, how many decimal places should it be? 2. So we're always going to do 3 decimal places unless we're talking about money, then we'll do 2 decimal places. So this will be 6.330 years. Right. How long will it take $1,000 to triple at 11% compounded continuously? So do we see the difference between the simple interest versus the continuously compounded? So this one will say compounded continuously. That's how you know you're going to use that formula. Who remembers what that formula is? You got it. All right, let's write this out. So how long will it take $1,000? So do we all agree 1,000 is our principal amount? To triple at 11% compounded continuously. So our rate is definitely 11%, which we'll write as a decimal 0.11. Now it says, how long will it take? So do we all agree we're solving for t? So then we need to know what a is. You could only have one unknown. Is e an unknown? No. So we could only have one unknown. So I know P, I know R, I know I'm solving for T, so I need to figure out what A is. So it says, how long will it take for $1,000 to triple? So if we're going to triple it, what does that become? $3,000. So now that we know for all of our variables, we could plug right into our formula. We're going to have 3,000 is equal to 1,000 e raised to the 0.11t. We're going to divide by 1,000 on both sides. And we'll get 3 is equal to e raised to the 0.11t. Now, in order to solve for t, I need to take it out of the exponent. But since I'm dealing with e, I'm not going to take the log of both sides. What am I going to take? ln, natural log, you got it. So I'm going to say ln of 3 is equal to the ln of e raised to the 0.11t. Well, isn't that a shortcut, ln of e raised to a power? Or it's log base e of e raised to a power? Isn't that just the power? Is equal to the ln of 3. So now we need to solve for t. So I will divide by 0.11. And in your calculators, you should now do ln 3 division sign 0.11. Tell me what you get to 3 decimal places. Evie?
9.987.
Perfect. 9.987 years. Augie, why do you look confused? What's wrong?
How did you get rid of the ln?
So this was one of the shortcuts we had to memorize. Remember, when you have ln of e to the 0.11t, this is the same as log base of e to the 0.11t. If you don't remember ln, just change it to log base e after you write ln. First write ln, then change it to log base e. All right, let's go on to the next one. So I feel like the banking problems are pretty straightforward. These next ones take a little bit of work. It's not as obvious. Okay, it says, if the population doubles every 20 years, how long will it take to triple? Which formula is this? Population, right? This is population growth. And this formula is n of t is equal to n sub 0 of e raised to the kt power. All right, let's just rewrite this out because it's been a minute. We know n sub 0 is the initial amount. N of t is the amount at the end. K is the growth factor or rate, however you want to call it, and T is time. Okay, so for these problems, what you want to do, it's actually going to be a two-step problem. The first thing you want to do in part A, we're going to find K for whatever specific problem we have, because K is always changing. So in part A, we know K is going to be our unknown. So that means I need to find values for everything else. So it says if the population doubles every 20 years, how long will it take to triple? So what I'm going to do is I'm going to let n sub 0, well, I'm going to let it be n sub 0 because I don't really know, and you'll understand why in a minute. So n sub 0, I'm going to let it be n sub 0. E is E. K is our unknown. That's what we want to find. What's T for this specific round? 20 years, exactly. T is 20.
Well, isn't the question how long would it take to triple?
Well, we're doing two parts. So I first have to find K before I can find how long it will take to triple. I don't have enough information right now to figure out how long it will take to triple right away. That's why we're making this into a two-phase problem. So now, do we all agree that NT is the amount at the end? Well, we want that to be doubled. So we're going to do 2 times n sub 0. So now I'm going to plug into my formula. When I plug in, I'm going to get 2 times n sub 0. Well, Michael, give me 1 second. Is equal to n sub 0 times e to the k times 20 power. Should I finish this part and then you tell me what you want? Okay, so now what I want to do is I want to isolate the e and the exponent. So I'm going to divide by n sub 0 on both sides. When I divide by n sub 0 on both sides, don't they both cancel? Move that down, something's happening here. Okay, so now I'm going to get 2 is equal to e raised to the 20k. Well, now we know how to solve this. So I'm going to take the ln of both sides. So I have the ln of 2 is equal to 20k. Ln of e raised to the 20k. I had jumped a step there. But what do we know ln of e raised to a power is? Just the power. So we're going to say ln of 2 is equal to 20k. I'm going to divide by 2. I'm sorry, 20, not divide by 2, divide by 20. And now we have k is equal to the ln of 2 over 20. We're going to use this now for our next phase. Yes, Michael.
No, you already.
It's okay?
I was gonna say the starting and ending amounts don't really matter. You just set it to like 1 and 2.
Mm-hmm. Can we keep going now? So this is not our answer. We did all this to find K because I didn't have my growth factor. Right, so now for part B, we're going to use K from part A to solve. So once again, I'm going to have n of t is equal to n sub 0 of e raised to the kt power. Okay, so Again, they're not giving us any definitive amounts. So my n sub 0, my starting point, I don't know what it is. I'm leaving it as n sub 0 because they didn't tell us how much it starts. It says, if the population doubles every 20 years, how long will it take to triple? They're not giving us a starting amount. They're just speaking very vaguely. So my n sub 0 is n sub 0, but this time my population at the end, I don't want it to double. I want it to triple. So it's going to be 3 times n sub 0. Now, k is my growth factor. Didn't we just find the growth factor? So the k is going to be the ln of 2 over 20. And now t is my unknown because it says how long will it take to triple? Yes.
Why can't we just divide ln2 by 20 and get like a number?
You can, but it's going to be a really long decimal. So when we actually put this into the calculator, it's more accurate than getting a decimal and just writing it out. Can we now plug into our formula? We sure can. So my n of t is going to be 3 times n sub 0. My n sub 0 is my n sub 0. And then e raised to the ln of 2 over 20t. I'm going to divide by n sub 0 on both sides. And now I'm going to have 3 is equal to e raised to the ln of 2 over 20 times t. Hey, we're getting pretty repetitive here, right? Now what do I do? Take the ln of both sides. So now I'm ln of 3 equals, do you guys care if I just go straight to the shortcut or do you want me to write it out? Okay, good. So we're going to have ln of 2 over 20 times t. It's probably easier to do this in phases. If I took these parentheses away because it's just multiplication anyway, I can multiply by 20 on both sides to cancel these out. So then I have 20 ln of 3 equals ln of 2 times t. And then I could just divide by the ln of 2. So t will equal 20 times the ln of 3 over the ln of 2. And this is what you're putting into your calculator. All right, somebody tell me, what did you get 3 decimal places? 699 years.
Is it always years?
Unless it's said differently. So, for example, in the next one, they're talking about days, so it won't be years. It'll be days. But this one, it says if the population doubles every 20 years. So they're telling us that frame of reference. I know this was a lot. I know it was different, but the next problem, we're actually going to follow a very similar style of solving it. Can we get started on the next one? What's up?
When did you get for the first one again?
The very first one?
Yeah.
I'm not sure. Let's go back. 6.330 years. Okay, let's do this last problem. The radioactive gas radon has a half-life of 3.8 days. How long will it take 1 gram to decay to 0.2 grams? Obviously, this is a decay problem, right? And so our decay formula is N of T is equal to N sub 0 times E. Now it's almost the same as population, but what's the only difference? It's a negative K versus a positive K. So this is negative K times T. For these DK problems, we're going to do the same thing that we just did for the population. You're first going to solve for K and then solve for whatever else they need you to find. So similar process, we're going to solve for K. So I have to then make sure I know everything else. So the radioactive gas has a half-life of 3.8 days. Okay, that's a word you need to know, half-life. Half-life is basically however long it takes. So whatever the half-life is, it takes that long to be half of what it originally was. So when it says the radioactive gas has a half-life of 3.8 days, that means it takes every 3.8 days, it goes down by a half. It's like dividing it by 2, the original amount. So let's see. How long will it take 1 gram to decay to 0.2 grams? So let's set up what we know. Well, do we know our original amount? 1 gram, right? Because it says how long will it take 1 gram? So our original amount is 1. And we need to solve for K. So I know my K is the question mark. Our time, well, it says the radioactive gas has a half-life of 3.8 days. So do we all agree our time is 3.8 days? And then our end amount, even though it didn't specifically say it, it says it has a half-life. So after that 3.8 days, aren't we going to be half the amount of whatever we originally had? So if I originally had 1, what is my half-life going to be then after that? 0.5 or a half, exactly. Probably easier to do 0.5 in this scenario since we're using a calculator. Okay. Can I now plug into my formula? Yes. So we're going to have 0.5 is equal to 1 times E raised to the negative K times 3.8. So we are 0.5 is equal to E raised to the negative 3.8 K. To get that K, yes, Evie?
How come the end amount wouldn't be 0.2 grams?
That's for part 2. So right now, we don't know what our K is. So we're trying to use the other information they're giving us to find K and then use that to then go on to the 0.2. So this is sort of phase 1 of our problem because we don't have enough information to go straight to 0.2. All right, so now let's take the ln of both sides. So I'm ln of 0.5 is equal to, I'm just going to use the shortcut, negative 3.8K. I'm now going to divide by negative 3.8. So K is the ln of 0.5 over negative 3.8. Okay, now that I have K, now I can go and solve what they were originally asking us for. I had to do this to find K because I didn't know what K was. So now in our phase 2, we're going to use K from part A to solve. So once again, we have our N0, our N of T, our K, and our time. Okay, so the radioactive gas has a half-life of 3.8 days. How long will it take? Do we all agree that this time our T is our question mark? How long will it take? Right, 1 gram, so our initial amount is 1 gram, to decay to 0.2, so my end amount is 0.2. And now, do we know the K for this problem? Yes, we just found it. So it's going to be ln of 0.5 over negative 3.8. And we're going to plug all of this into our formula now. So our 0.2 is equal to 1 times E raised to the ln of 0.5 over negative 3.8. Oh, sorry, this should be a negative K, right? Sorry. So if my K is negative ln of 0.5 over 3.8, won't it now be ln of 0.5 over positive 3.8? Times T. So I'll just write out the formula again. N of T is equal to N sub 0 of E raised to the negative K times T power. And that's where we plugged all that in.
I wonder where the 0.2 comes
From our word problem. So it says,
from.
how long will it take 1 gram to decay to 0.2? Tammy, was that your question also? Okay. We need to solve. So we have 0.2 is equal to E raised to the ln of 0.5 over 3.8 times T. We're going to take the ln of both sides. So this will just shortcut into ln of 0.5 over 3.8 times T. We could lose those parentheses. So I'm going to multiply by 3.8 on both sides. So these will cancel. So then I'm now going to have 3.8 ln of 0.2 is equal to ln of 0.5 times T. So last step is to divide by the ln of 0.5. And this is what you are putting into your calculators. T is equal to 3.8 ln of 0.2 over ln of 0.5. Hey, can somebody tell me what you get to 3 decimal places?
8.823
Perfect. And now what is this?
days.
Days. We need our units. All right, we're done for today. So I'll post your homework. You guys can get started on it in case you want my help. I don't know how much time we have left. Yep.